All right, welcome to the video for 8.7's answer key. I'm going to go through the even problems and I'll leave the odd ones for you to do. All right, so for the first one, we have the base of a solid is the region in the first quadrant first quadrant bounded by the graph of y equals cosine of x and the x and y axes. So if we draw a picture of that, that looks like cosine of x starts at 1 and goes to pi over 2. All right. For each solid, each cross section perpendicular to the y-axis here, right? So we're thinking we're going to the y-axis is a rectangle whose height is 4 times its width. So if we say this is the width of the rectangle, then the height of the rectangle would be 4 times this. So it'd be like that, or this one would be like that. All right, so it gets wider, or it gets taller as it gets wider. Um, what is the volume of the solid? So to find the solid, what we're going to have to do is we're going to integrate the individual areas of each of these rectangles. We can find a formula that provides the area of each of these rectangles. Then if we integrate over the length 0 to 1, we'll have the total area of each solid combined, which is the same as its volume. So if we think, all right, since this is perpendicular to the y-axis, right, then we're going to have to integrate with respect to y, which means that the limits are going to range from 0 to 1 of, all right, let's find the width of this rectangle. So the width of this rectangle is this function minus 0, but in terms of y. So if y is equal to the cosine of x, and we want to solve that for in terms of y, we would take the inverse cosine of both sides. X would be the cosine inverse of y. So that is the width of the rectangle. To find the area, I need to take that width and multiply it by the height. And we're told that the height is 4 times the width. So that's easy. This is the width, and then the height would be 4 times that. And then to find the volume again, or find the area, I would just multiply those together and then integrate. So my volume will be the integral from 0 to 1 of 4 cosine inverse of y squared dy. And then, since this is calculator allowed, once you have it read, you'll grab your calculator and we'll type in the, let's move this over, math 9 from 0 to 1 of 4 times the cosine inverse of x, x. I just want to go in between the parentheses. Well, maybe I'll insert another set of parentheses. I could get around that. Okay, there we go. Squared. Yeah, that should do what I hope it should do, or we could double check. Enter. So 4.55 or 4.566. So that's going to be D. Let's double check that I typed that in right. Yeah. All right, very good. All right, so again, the idea is you just find the area of whatever shape that it's telling you to do in your region, then you integrate over the entire region, you find the area of each figure that they tell you, like square, rectangle, or whatever, and then you integrate over the length of the region where we're making those squares and rectangles or whatever. All right, so number 4, let's try another one of these. So the base of a solid in the first quadrant is graphed by y equals 1 minus x over 3. So that's just a linear equation with a y-intercept of 1. and a slope of what, -1/3. So if I went down 1, I'd go over 3. So this is 1, this is 3, this is the area. Each solid, for each cross section is perpendicular to the x-axis is a square. So the idea here is for a square, the width and the height are the same thing. So this will be like that, and then this will be like that, and they'll be tidier squares, right? As you get closer and closer. So this is like, it starts out really high and then it gets smaller and smaller as you get to over here. What is the volume of the solid? Well, again, I'm going to integrate this time with respect to x from 0 to 3 of my function. All right, of the area of each of these, the shape that it's telling me. So to find the area of a square is actually really easy. I just take the side length, right, which is however tall this is. Right here, it's 1 minus x over 3, 1 minus x over 3, 1 minus x over 3, right? That tells me the value of y at each of those points. That'll tell me the width of each of these squares. And that's the same as the height, right? It's a square. Width and height are the same, so I just do 1 minus x over 3 squared dx. Now this one is not calculator allowed, so they expect you to be able to do this by hand. So if we, before you actually integrate, what I would do is simplify this and go ahead and square it out. If you take, if you do the distributive property here, 1 minus x over 3 times 1 minus x over 3, 1 times 1 is 1. 1 times negative x over 3 is negative x over 3. Negative 1 times, or negative x over 3 times 1 is the same thing. So that would be what? Negative 2 thirds x. And then negative x over 3 times negative x over 3 would be positive 1/9 x squared. All right, and then to integrate this is just the power rule. So I don't need that notation. So the antiderivative of 1 is just x. The antiderivative of the second term, I always do the power first, so it'll be x squared. And if I take 2/3 and divide it by 2, my new power, I would get 1/3. But these lines are popping up there. All right, if I do this one, it would become, by new power, if I add 1 instead of subtracting, because I'm doing the antiderivative, and then divide, I would get 1/27th. And then I'm going to evaluate that from 3 to 0. So I'm going to plug in 3 to all these x's, plug in 0 to all these x's, and then subtract my two answers. The nice thing is if I plug in 0, it's just 0. If I plug in 3, what would we get? We'd get 3 minus, what? 3 squared is 9. Divided by 3 is 3. 3 cubed is 27. Divided by 27 is 1. So this is 1. Answer C. Let's double check that. Make sure I didn't mess up. Yay, look at that. All right, last melon. Okay, so for this one, we're given a graph. Let R be the region, draw it here. Given by y equals x cubed, that'd be this one. Y equals 4x, that's a linear equation. That'd be the one on the left or the one on the top. The region R is the base of a solid. For the solid, each cross-section perpendicular to the y-axis, right? Perpendicular to the y-axis. So that means, again, we're going left to right, right? Is a square. Hey, that's easy, right? So you think like, okay, is a square here? Is a square here? Square here? We've got this shape. This would be a really tiny square. This would be kind of bigger square. Look at all these squares. It'll be like get bigger and bigger, and then it would get smaller and smaller. All right, so if I want to find the volume of this shape, which is made up of all these, each cross section of this shape is a bunch of squares. In order to do that, because I'm doing from the y-axis, I'm going to integrate from 0 to 8. And to find the area of a square, I would do its width squared, right? Because the width and the height, they're the same thing. So how do I find the width of each of these squares? Well, again, I'm going left to right. So it's just the right function here minus the left function. But I do need to make sure they're in terms of y, which they're not. They're in terms of x right now. So if I solve this for x, I would cube root both sides to get x is y cubed. That's this one. This is y cubed. To get the left side here, I would divide by 4. So this function on the left is y divided by 4. And again, to find the width, I would just take x, or the cube root of y, and subtract y over 4 and dy. That's y over 4. All right, and then I believe this one's calculator allowed. If I go back up and double check, and it is. So that to find this one, we would just grab our calculator. We would type in math 9, integral from 0 to 8 of the cube root of y. So I'm just going to do x to the 1/3 power minus x over 4 dx. All right, and that'd be 4. Which means its answer, oh no, not 4. What? Maybe I typed it in wrong. Let's double check my math. All right, so it is from 0 to 8. Okay. Each cross section perpendicular to the y-axis. That's great. If I solve this, this would be the cube root of y. This would be y divided by 4. I do the right minus the left. That gives me the width. I feel pretty happy about this. Maybe I typed it in wrong. I don't feel like I did. Let me double check. What am I missing here? Yeah. Y. So it'd be the cube root of y to the 1/4 of 0 to y. Oh, I forgot the squared. God, I talked about the squared and then I forgot to square it. What kind of Yahoo forgets to square when they talk about the squared? Squared, because it's squared. That's the base times the height. God. Golly gee willikers. Okay, so then can I just copy this? And then add another set parentheses. Second, insert parentheses. Squared. There we go, 2.438. Now, is that an option? Yeah, that's an option. That's B. Is that the correct answer? It is. All right, good. Keeping you on your toes for that last one. Making sure you watch the video all the way through and pay attention. Probably. Yeah, totally intentional. All right, well, thank you all for watching. If you have any questions, you can email me or join our office hours for Thursday or Friday. Have a good rest of your day.